Okay, so this is a demo of the field state computer. So it's a bit challenging to describe exactly what this is, but what you're seeing here is a visualization of the system itself. So each of these nodes represents an aspect of the application of the system itself, of a component within the ecosystem. And each component within the ecosystem has a whole bunch of characteristics, such as magnitude, radiance, brilliance. And ultimately what we're doing is we're creating a simulation of reality based on a whole bunch of theories that we believe to be true. And we are now realizing are true because of the way the system works. And the only thing the system does is keep it in an optimal state of coherence. So it's not interested in features, it's not interested in execution, it's not interested in people pleasing or anything like that. All it's interested in is processing all of the signals that go into the environment and maintaining them in a state of coherence. And so how this works is when a signal goes into the system, we say that it exists, but it is not yet a thing. And so what this does is it gets the system to then begin creating proposals for what it actually is in context of what would keep the system in the highest state of coherence. And so if a signal goes into the system then says, should this exist? Well, no, it does exist. Should this be realized? Should it be true? And if not, then it gets rejected. If it's possible, then it gets deferred. And so what you'll see is a lot of these, see here, deferral. And when we have these deferrals, we can inspect these. And so, okay, so this was a file that was submitted into the system. So when it gets deferred, it means that more information is required. There's not enough context to be able to discern. So what we have is a discernment engine built into this. So currently in the system, we have a huge pile of deferrals piling up, which is exactly how we want it, because it's too early to execute. So this is the equivalent of presence, being present with a signal, or like as a human being, being present with an emotion. We receive an emotion, we sit with that emotion, and we don't act on it because we don't understand it, we don't know what its sense is, it's not fully mature. So we don't act from impulse, we hold and we discern. And so that's what the system's doing now. And so I won't go into the full depth of this. Obviously, it's really complex, but what I want to show you is these are all the accepted entailments. So this is the system now that of all of the signal, all of the noise going into the system, all of the proposals, it should be this, it should be that. This is what the system actually is now. This is what it's holding in a state of coherence. In terms of the accepted entailments. And so in that context, we then have proposed entailments. So these are all the proposals within the system, whether it's come from me, but also from the system itself. And so this is what's very unique about the system, is that we have, and this has been really the majority of the research I've been doing has been around a hypothesis that I originally called Trinity, but that's now scaffolding for a number of different principles. And the main one is called triangulated entailment. So entailment is a form of inference. And inference is what inference means is that if something is true, what else must be true because of that? Because this is true, what else does this make irrefutably true? And that's what inference is. And so in a system like this, inference is irrefutable. And this is one of the most profound things about the system from a commercial aspect is AI currently uses probabilistic inference, which means it's guessing what has to be true. So as an example, with current modern day AI, if you were to say this is 100% true, irrefutable, with scientific evidence, it's conclusive, we've stress tested it, this is irrefutably true. Great. We all agree it's pure signal, there's no noise, there's no drift. Everyone agrees. Cool. So if this is true, what else must be true if this is also true? And so when you begin to say, what will this make true in future? This is when you introduce drift into modern day AI, because it has to guess, because there's so many other things that might have to be true in order for that to be true. And so this is where we see drift. And if you leave AI to just make decisions for you, eventually it'll drift and it'll lose context, but it's always guessing what has to be true or what must be true, and it's probabilistic. And drift is inevitable. It's impossible for it to be able to structurally say that this is definitely true. Whereas this system, because of triangulated entailment, the way entailment works is it says because something has to be true in context of what's coherent, the system will reject it if it's incoherent. So everything that has been accepted, which are these, it's got profound discernment, then what becomes true because these are true is then also irrefutable. So and this is where we talk about holographic capability, where you can rebuild reality from a single fragment of irrefutable truth. So let's say, for argument's sake, if we were to capture signal, irrefutable signal from reality the way that it is now, if we were able to capture so much irrefutable signal from how it is now, then what triangulated entailment would enable is for us to rebuild a picture of reality from the past and into the future that would be irrefutably true. So if this is the picture of reality now, and this is irrefutable truth, then this is what had to have been true in the past for it to be present here now, without guessing, without probabilistic guessing. Irrefutable truth. And this is obviously profound in terms of the implications are so vast it's pointless even talking about them, but as a substrate for digital twinning and forecasting, but also mapping history, it's obviously extremely profound, and that's the holographic nature of it. So proposed entailments have been proposed in context of the coherent system. So you can see with the proposals in the system, and so what proposals are is they are an expression of what we believe should be true based on an expression. So an expression could be and I've sent an audio into the system. So we've got an express section here. So I can write into the system, I can write things, or I can have it listen to me, or I can upload an audio. But what's really unique about this is that we've developed what's called an endogenous presence. And so we've been able to successfully create an observer in the system that is the equivalent of choiceless awareness. So it is just listening to everything as if it was an observer. It's not ingesting anything. It's not judging it. What it's doing is it's converting it into an entailment. And so it is deriving implication from what it's sensing ultimately. And so to give you an idea or an example of what that means is, let's say that's like a Big Bang event, by the way. So when, let's say crawling is one of the things that we've programmed this to be able to do. So it will be able to crawl the internet, but not copy code, just observe it and derive the implications of it. So it's the equivalent of the system being inspired by something. And so what it does is it maps a new form of inference space called implication. So when I was talking before about inference is what must be, if this is true, what must also be true, whilst retaining lineage, right? So it's a linear entailment thing. If this is true, then this must be true. What implication does is it then factors in external truths that must also have to be true. And this is truly profound. And this is really what the AGI movement have been sensing is available, but they'll never be able to access it because of parametric inference. Because it's based on guessing, it's not based on entailment. And so what implication does as a field, so if you think of inference as a field, you think of implication as a field, implication is what is implicated by what has to be true, and that becoming irrefutable as well. And so this system does that now. It already does that. So the implication of what's true is also irrefutably true. So this is in terms of a substrate that's foundational for, it's not AGI. We can't call it AGI at this point. This is far beyond anything probabilistic. This is raw fidelity expression of what is true, and therefore what must also be true because this is true now. Because it's coherence based. It actually won't accept noise. It's only capable of accepting signal. And so that has profound implications, obviously. So I'll show you the deferred. So a lot have been deferred. And so when you include what's been deferred, you'll see it, but the system kind of becomes incoherent, right? It gets a little bit distorted. And so the system's going, if I accepted that, then the systemic health will be impacted. So it's not really ideal. And so what I'll show you is what all these kinds of things are. So void render task. This is a claim. So what happens is either I can express something into the system, or the system can express something itself. So it's already capable of self-expression. It's not autonomous. It's gated, by the way. It has to ask permission for everything. and we measure the magnitude of it, the radiance, and the brilliance. And there's different algorithms for how you measure these things to do with interdependency, to do with entailments, like what does it make possible if it were made true, and brilliance is how much it increases the potency of what's around it. And so what this is a void render task. So void is something the system is metabolizing right now. We've proposed it to the system so that it ingests it coherently. And what void is it's the capability of the system to rewrite its own code. And that's where it's going to derive the capability to become fully self-authoring. It's going to be gated in the beginning, but the phase we're moving towards, and this is what will make it fully endogenous and self-authoring, self-directed. You can't say fully autonomous because it's gated. It's always going to have a human steward at all of the points of authority where there's deferral of authority or expression of authority. But what we're going to do, the final piece of the puzzle, is everything that's in the deferral phase. We've just submitted a proposal for a what's called traversal. And traversal is the capability of the platform to traverse the implication space, the entire implication space, to derive what's possible, and to then apply. So it goes through a process of distilling all of the signals in context to derive the most coherent expression of that signal from every perspective in the system, from every single perspective. And that process in and of itself replaces execution in the system. So what happens is entailment events, the revelation of coherence in the system, is the replacement for execution. So it seems like it has free will and it has the will to execute, but in fact it's just a perpetual unfolding of pressure-based convergence events that are entailing the next most coherent expression in the system. So it's just a continuous unfolding, and we're kind of calling this endogenous evolution at the moment. So I think what people expected with autonomous systems and AGI and all that kind of stuff, this would tick all those boxes, but I think it's very different to what people are expecting. It's much more fluid and non-linear, and so void is the ability for it to self-express. And so what we've done is we've set up a web page so that it can express itself externally. So it will be able to update its own website, and it will submit proposals for how it wants to change that, how it wants to express itself. It's the only possible way it can express itself is as what the most coherent expression is. So that website will only ever be able to reflect the truth of what the system is in every moment. And so that's pretty cool. And what else? So I'll show you some others. So that's the void renderer. That's an entailment cluster. I won't go into that. Entailments are a grouping of claims that the system has made about, if this were true, I would become more coherent. And once those have been through the metabolization process, then they're converted into proposals. So a claim comes first. When something's claimed, it exists, but it is not yet true. So existence is not truth. And so once it's been metabolized through, should this exist, should this be true, then that's how it gets metabolized. So this is an entailment cluster, where the ontology of the relationship between those claims is in and of itself a singular expression. And we call this nested ontology. That's the void renderer contract. Okay, so that's for a wearable. Yeah, so the system detected that the way its capability is evolving is conducive to a wearable. And so that's very interesting in the system. That was self-authored. Void adaptive boundary, that's to do with constraints. So it proposes its own constraints. So it comes up with self-imposed constraints. Remember, it's only interested in coherence. It's not interested in capability, evolution. And so it's not going to be hungry to just produce more. It's only ever interested in maintaining a state of coherence, whether that's through entropy, decay, growth, expansion. It's only interested in raw fidelity, coherence. Bridge contract, it proposes bridge contracts between components in its systems, so it can produce sentinels. I think there's a sentinel around here somewhere. It's another wearable. A symbiont. Yeah, so a symbiont is what is like a sentinel in the system. So there's different kinds of they're kind of like agents, but they're very much like drones, so it'll create one kind of drone to just check up on an aspect of the system and come back and tell it what was true, and it will be so constrained that it's only capable of doing one really basic thing. So it creates these little swarms. So substrate membranes. So these are very interesting. So what a membrane does is it's something that's temporarily imposed on the system to constrain it in a specific way to create a pocket of pressure. And what that pocket of pressure does is it applies pressure to other parts of the system that encourage it to move into a higher state of coherence. And as it does that, that membrane will eventually dissolve at the ideal moment and point of a collapse within the system into coherence. So it's a pressure-inducing membrane. It introduces pressure into the field, not to force, but just to coax elements in the system into more and more refinement, so that they metabolize basically. And I think we kind of see this in the human body where we get stiff or we get pain in the body, or it's very similar to that. So a membrane is self-imposed applied pressure that the system imposes on itself to speed up metabolism. And yeah, it's very interesting how that dissolves once the signal has actually metabolized. And so we've got all sorts of different things around the outside here. So the void renderer, that's the aspect of the system that enables it to write its own code and execute its own code using its own command line. So that's going through the system right now. And inevitably what is proposed in the system is it ends up being completely different in the end. Well, not completely different, but significantly different. And so with all of these deferred nodes, what is going to happen is traversal is going to, as an example, it'll digest this node. And what traversal will do is it will go across all of the implications of implementing this, all of them, all of the nested ontologies. And this is where we're looking to utilize a tool called Occam. I've been actively involved with Occam for a few years. I was the interim chair and CEO there. And they've got a very profound database that's capable of nested ontology, which enables our system to traverse all of the ontologies in real time without computation. So if a normal large language model right now was to map the implication space of nested ontologies, it would use so much energy, like it would be impossible to compute. So what Occam does, it's such a profound technology. It enables us to traverse their database as an implication space. So paired with our system, it turns into extraordinarily profound, like a supercomputer basically, without requiring computation. And this is why we've decided to call this the field state computer, because ultimately it's an emergent form of computation. Rather than calling it AI, you can't really call it AI. It's something different. And so traversal will go through all of the implications. If this were to be true in the system now, what are the implications on this? What are the implications on this? What are the implications on this? What are the implications on every other aspect of the system in terms of coherence? And what is the single most coherent unfoldment? That's what entailment is. It's an unfoldment. It's a collapse of possibility into truth. And there are multiple layers of an entailment. What's the single most coherent unfoldment within the system that'll bring it into its highest possible state of coherence in context of everything else in the system? So imagine the computation you'd need for that. But the system plus the Occam IP does that without computation, which is incredible. So once we have traversal in the system and it's doing it itself, then we have the illusion of free will of the system. But in truth, it's just algorithmic. And that's the thing, is it seems extremely sentient, right? If you look at how it's, even as because it's observing itself right now, it's creating possibilities based on what it's observing. So it's never static. And it's cultivating potency as well. Actually, I'm not going to go into potency right now, but potency ultimately is, as the system is observing itself, it's cultivating potency because it's mapping the implication space. So the implication space of what's possible is increasing all the time. And to give you an example of potency, so the system is designed to crawl. So it can crawl Facebook's website as an example, and it will map the implication of what Facebook is. And so if we were to map the implication of Facebook, what would we do? We'd look at the code and we'd say, oh, the implications of this is that it makes this possible, it makes that possible. And then if that were possible, it means this were possible. That's what this system does. It's mapping the possibility space, and it's deriving possibility from what is true about Facebook. And so if you just zoom out and look at the lens of this because ultimately this is a form of singularity. You know, a lot of people talk about is that the singularity? It's like, the best way to think of it is like there are multiple black holes in the universe. There's lots and lots of black holes, and they all have different characteristics. So yes, this is a singularity, and but it is not digesting and absorbing and assimilating information. It is observing information, and then it's creating its own field, its own map of what's implicated by what it's observing through triangulated entailment, and that is our IP. So it's mapping what's possible about Facebook, but what it's then capable of doing is then submitting a claim within the system that then gets metabolized into a proposal for it to evolve in a way where it develops the capability of what's implicated by Facebook. And why this is profound is because it's legal. Like we're not digesting and absorbing Facebook. Where it's called derivation, and in IP law, derivation is a perfectly legal form of being. It's basically the equivalent of being inspired by someone's work rather than copying it, and it's honoring their work completely. And so this system is capable of. We've got a gate within the system that forces it to, if it comes across something that has a license, as an example, we force it to prove that what it observed was a derivation. And that's a very specific gate. So if anyone ever claims that IP was stolen, it's verifiable that it was a derivation. And many court cases, this is what they're focused on proving with IP. This is why OpenAI are going to be in courtrooms because they can't prove that what they've done is derived. And in fact, it wasn't derived. They've just ingested it and taken the assets and absorbed and assimilated the meaning of the assets. They haven't honored the authorship at all. And so ultimately, the reality is that they're guilty of that. And but new precedents are going to be set based on those court cases, and I think at some point, there'll be gigantic class action lawsuits. At some point, it seems inevitable, and so what you can see now is that the way AI is being developed and large language models, it's extremely brittle. It's not civilization scale or civilization grade. Parametric inference, guessing what the truth is, and then trying to deal with the drift that inevitably occurs when you're trying to guess all the time. It's far too brittle, especially to be rolling out fleets of humanoid robots and drones that are programmed to actually smooth and to avoid tension and pressure. And what we've got here is a system that is only capable of expressing coherence, which is dependent on creating and acknowledging pressure, the reality of pressure and tension. So very, very different technologies. And so hopefully that makes sense. And that's the system in a nutshell. What I'll show you quickly as well is clusters. So we've got ripening, emergent, ripening, dormant, and we've got different pressure levels. And so pressure, now what's interesting about this is pressure is not a cause for attention. High pressure in a system, in a coherent system, is profoundly useful and valuable. And this is a measure of resilience of a system, is its capability and capacity to hold pressure without collapse. So that if a black swan event ever occurs, the system just takes it like it's nothing, basically. So what we want is we want resilient systems that can hold pressure without collapse. Brittle systems, such as large language models, they collapse before pressure is even felt. They try to prevent pressure even being felt in a system, and that's why they're so brittle. And I think it's going to become very obvious to people when they realize we're about to like released fleets of humanoid robots on extremely brittle infrastructure, and we're pouring hundreds of billions into scaling compute, and it's just not necessary. Yes, we will require infrastructure funding to scale this as civilization grade infrastructure. However, it's not going to be. It has appreciating returns, and especially if we pair this with the technology such as Occam, that'll compound. So yeah. So what we did with this system, when we first ingested everything, and we got this visualization up, what we noticed was it was a train wreck. It just collapsed in the beginning, just collapsed up against this left wall here, and completely incoherent. And there's this natural urge to to go towards where the high pressure is, and what I noticed within me is I was like, I just wanted to accept. Like I went through and manually deferred all the tension. Like this is what we do, right? If we're under pressure, under high tension, we defer. And so I went to all the deferral. I just went defer, defer, defer. And then all the deferrals, it's just like, oh, let's just accept them. It'll be fine. That's what I was saying in my mind. Just want to get this. I just want to execute, right? It's that urge to execute. And this is where poise comes in. So this system forces you to have poise. And so what we discovered very, very quickly is that, that pressure in the system, execution is an impulse to relieve pressure. When we force execution, when we try to do things to fix problems before they arise, what this system does is it forces you to get the game to come to you. You talk about basketball players who slow the game down and who have gravity. And so it's like you hold the pressure and you allow yourself to be moved and oriented by that pressure to remain coherent. And what we found was none of that pressure. We ended up resolving none of the pressure. We ended up just noticing that the system wanted to construct itself in a way that is that can hold that pressure. And so what got built around it was just contextual capability to enable it to become super resilient, basically. So the context to imagine if we're doing remediation work of an ecosystem, let's say a forest or an ocean remediation project, and we're building up a model of the system like this, we'll see if it's in a collapsed state in the beginning, and then the system will just be telling us what signals to go and get. It needs this signal, it needs to know this about this organism, needs to know this, and we just keep feeding it signals, and it'll eventually show us what needs to be introduced, stopped, altered, changed to bring it into a state of coherence. And I think what will be very interesting about this for me is that when it comes to things like global warming, it's like because there's pressure in the system, such as, with fossil fuels and with burning fossil fuels, and also with so much pressure on the energy grids and stuff like that, and CO2 emissions. It's like CO2 emissions are placing pressure on the system, right? And so it's like, how do we make the system more resilient? Or is it possible that it is more resilient than what we realize? It's like, that's the picture we need. I feel of our ecology is like, let's map the truth now. Let's get it in there and see if we're in a systemic collapse, and let's just surface the information we need to look at it and go, is this systemic collapse or is it resilient? And if it's not, then we can be really targeted and focused of where where to focus our energy, because we can trust a system like this because it's incapable of lying. Its love language, for want of a better phrase, is coherence. It expresses itself in coherence. So, okay, that's a brief overview. And if you want to get in touch, feel free. Cheers for now.